Hello, this is Kelly Park from Cited Society, and today I'll be teaching you how to make a CD hovercraft, then explain how it works. This is the CD hovercraft. Here are the materials and tools that you need. First of all, with the shiny side of the CD facing up, use the hot glue gun to glue the cap to the center of the CD. Make sure to create a good seal to keep air from escaping and keep the pop top closed. This is pretty much it. Blow up the balloon all the way and pinch the neck. We are not tying the balloon. Fit the neck of the balloon over the pop-up portion of the cap. You may need to ask help from somebody around you. And that's it. When you're ready, simply pop the top open and glide the CD hovercraft over a smooth surface. To understand how the CD hovercraft works, we need to learn about friction. What is friction? It can be said that friction is a force between two surfaces that are sliding or trying to slide across one another. In this clip, the two surfaces interacting are the wooden block and the floor. As the person tries to slide the wooden block across the floor, there will be a force of friction. Since the CD hovercraft was sliding across the surface of the table, there was a force of friction between the CD hovercraft and the table. Just as this image illustrates, friction always works in the direction opposite from the direction that the object is moving or trying to move. Since the pushing force is directed to the left, the friction will be directed to the right. This image also illustrates the same point. Again, friction always works in the direction opposite from the direction that the object is moving or trying to move. The red arrow is the force applied and is directed to the right, while the blue arrow is the force of friction and is directed to the left. Another key point about friction is that different surfaces have different amounts of friction. Picture yourself trying to bike in a rocky terrain versus a skating rink. In which surface is it easier for you to accelerate on your bike? It is easier to bike on a smooth skating rink because it has less friction than the rocky terrain. Examples of everyday objects with high friction include the following. Examples of everyday objects with low friction include the following. By now, you may be able to realize that the CD hovercraft worked because there was somehow a way to decrease the force of friction between the surface of the table and the CD. How can we reduce the force of friction between two objects? Here are just 3 ways. Number 1, reduce the contact area by using rollers, ball bearings, or wheels. Secondly, change the surface of the materials that are touching by using lubrication. An example of this can be using oil while fixing gears on a bike. Finally, create a cushion of air. Can you guess which of the methods was used in the CD hovercraft? If you guessed number 3, you are correct. As the balloon contracts, air is pushed through the holes of the CD. This air escapes out from under the CD in all directions, and it creates a thin cushion of air that the hovercraft floats on. The cushion of air dramatically reduces the force of friction between the CD and the surface, allowing the hovercraft to move freely over a smooth surface. Now that you have your own CD hovercraft and know the science behind how it works, try investigating more on your own. Here are 2 extensions that you can try. Test the CD hovercraft on different surfaces. On which type of surface does it glide best on? Try blowing up the balloon to different sizes. Which size of balloon allows the CD hovercraft to glide for the longest amount of time? Why do you think this happened? I hope you enjoyed this video and make sure to check out other videos that our club has prepared. Thanks!